So I'm part of the system integration. So system integration in our organization is in the center. So you have the domain teams that are doing all the development. They have the technical expertise. And you have the customer and partners, the system tests. They are doing all the tests on the weekly release. And system engineering that is doing some documentation and the program management, of course. So in this talk, I will be talking first about what is Google giving us in Android, what is the continuous integration process given by Google. Then what we can find when looking at Buildbot and what is the usual way people are using it. And then the first step of continuous integration, what we can do to automate the boring part of Android integration. After that, we will see how we can really fit Buildbot inside our organization to really use it to full power and the challenge. So please feel free to participate if you have a question. If it's not very clear, then just interrupt me and I will answer your question. So first part is about the continuous integration of Android. So Google is shipping Gerrit as part of his open source suite. So basically it's a server that you run inside your intranet, and the developer is using the repo command to upload its patches, and then there is a reviewer that is doing feedback and approval, and also there is a maintainer that is doing patch pre-integration and smoke testing. So here, for example, this is the UI of Gerrit. So how many people are familiar with Gerrit? Okay. So basically, you send a patch, you have this page. So this is the developer, and you have the reviewer that is ensuring that the patch is doing what it claims. So here you can see what the developer thinks that he's doing, and after that you have the patch set, so you know what the developer is really doing. So the purpose of the reviewer is to really ensuring that the patch is doing well. So really the Gerrit, for those that don't know about it, it's really useful. I think it's the best UI I ever seen for review, and you can compare each version of a patch to see what exactly the developer has changed compared to what you approved before. It shows the white space error. You can configure the number of context line you want to display. The only feature that is missing is you don't have the function that you are on. This is a feature of simple feature of diff that you don't have in Gerrit. But okay. So then you have the maintainer. The maintainer is integrated the patch together. He's supposed to make a build and verify that the system still works. And so here are the little slide about the nodes meaning. So V+1, it means that the maintainer has tested the patch and it resolved the issue and does not add any regression. So the V-1 is where it has tested the patch, but it does not fully resolve the issue, or maybe there is a regression on other features that the developer might not have tested. And CR+2, it's when the reviewer really approves the patch, it's okay, it's ready for merge. +1, it means that the reviewer agrees with the patch, but maybe it's not so sure, or he needs a senior reviewer to approve because it doesn't have the rights. For us, in our process, we also use this +1 and have some rules saying that if the owner of the patch, if the developer is putting +1, then it means that the developer is ready. If the developer has not yet put its +1, that means that this is still a working on patch and it's published just for other developers to work on it, and it doesn't deserve to have a validation working on it. So -1, it's when a reviewer has some change, so rework is needed, and -2 is when really the patch is not doing things correctly and you don't want to have it in the build. So one of the limits of the reviewer things, it's sorry.
Hey, Pierre. Is it okay to use Buildbot to as a backup for your patches? So if you're currently working on
yeah, so to use Gerrit.
You said Buildbot.
Yeah, you mean Gerrit. Yeah, actually Gerrit is a full system for Git publication. So when you are using Git is only client tools, and you need a Git server. So there are a number of available Git servers. So there is Gerrit from Google, there is Gitorious, there is GitHub, there is Cgit, there is SSH over Git, and you can have several servers. So Gerrit is a full Git servers with a lot of infrastructure to actually duplicate, doing some mirroring, that kind of stuff. So yeah. The limits about the reviewing, it's really our experience is that the reviewer, they are doing a hard job, and you don't do that for more than 6 months, because after that you are really fed up with this job. It takes a lot of time, and it's really hard to fingerpoint other jobs. Actually, even that there is some cultural problem for some people to tell the bad things. So on some cultures, it's very difficult for people to tell others that this is bad code. And also, we have as we are in the phone area, we have a lot of time to market pressure. So the developer is under pressure and is always fighting, and the reviewer needs to have enough power to say no, this patch has to be reworked. And so I've talked about some other people from other companies that are saying to me the same thing. It's that the review is often neglected, and usually people just put +2 and we submit the patch and that's it. So it's a bit a problem, because it's a technical debt. Once you have hacks, then it's you will pay the price all the time. You will have to deal with the same code area. Then there is a hack on it, so I have to work on around that. So yeah. So then, what is Buildbot? Buildbot is a build and test automation framework. So there are several on the open source market. There are other in the proprietary market. I won't talk about those. The advantage of Buildbot is really easy to customize. The configuration file is written in Python, so it's really easy for you to just customize some part of the process. It's not just like you are binding to having this and this configuration parameter, and you cannot go away from that. You can just redefine your steps and change their behavior to suit more your needs. And that is a very cool fact about Buildbot. The problem with it is, so this is why it's very popular with open source projects. Because open source guys want to have customization. But in the industry, I have seen a lot of people using Jenkins because it's so easy to set up. It's just like 10 minutes, you uncompress you install the jar files and it's running. It's really easy. And with Buildbot, you have to read the doc. And the doc is actually well done, so it's not that much difficult. The other thing with Buildbot, it's written in Twisted. So I don't know if you are knowing Twisted. It's really fun. Asynchronous programming. It's very powerful, but quite unusual. And so it's quite complex when you are starting to really really want to change deeper in Buildbot architecture. Then you have all those asynchronous function callbacks and then you need to care of. You need to handle all the error cases in a very particular way. So it's not everybody can work on that. It's kind of time consuming. So here is an overview. So this is kind of classical. You have a build master, which is the server, the Buildbot, and you have the Buildbot is connected to several kind of repository. So there is a lot of plugins that supports repository, and whenever there is a change on that repository, the build master can take can launch some builds, and it will just send commands to the build slaves. So the slaves are really dumb. They don't implement any kind of smartness to do something. It's all implementing in the build master. Basically, the build master is only sending shell commands to the build slave, and the build slave will run it. So and then also in the architecture of Buildbot, you have the notifiers. So several notifiers are possible. You can, when the build is finished, you will send an email. You can have also the notifier. You have the web status that is showing you the results in a web UI. You can have some message posted to IRC, and also you have something that is quite good, is the status client. So you can write another web UI that is looking at this status client, and you can display your results differently than the original Buildbot UI. Here is like a screenshot of how the Buildbot is working out. So this is on the Buildbot. So this is the Buildbot that is testing and building Buildbot. So each time here, this is the maintainer, Dustin. We see here, you have send a patch. If you were on a UI, you can see what the patch is about, and it will just trigger a lot of builds at the same time. So this one is for testing if it still works on Python 2.6. This one, if it still works with this DB, and this one is for Python 2.7. So here everything is working, and in the event where the thing is not working, then automatically the developer will receive an email, and once he receives the email, he just needs another patch, and we send the build, and it was okay. So it was just a small mistake, but eventually, if at that time there were some people that were synchronizing the repository, it will eventually have PostgreSQL not working, and that is bad about this kind of continuous integration, is that they are done after integration. You commit, and then you have the alert like 1 hour after the commit. So it's too late, and so it's not too much. We want to have message before. So the classical solution that often people are having is to ask developer to submit their patch in another branch than the main line, and then you configure Buildbot to react on these pushes. And once Buildbot is happy with your patches, then you merge, and so you are sure that the merge is okay. Your patches are okay on everything that is supported. So it's hard to scale this kind of branch triggering for like 200 devs, and it will produce too many branches in the repository, and it doesn't work really well with Android, where you have 200 devs plus 200 repository. So it's not using for us. So here is like a slide I've taken from Urban Code. It's a bit small, but it's like the state of the art. What you are doing, when you are doing base build. So basically, you just have a build script, and you have a build machine, and this is the base. And when you are beginner continuous integrator, you are starting to do some cron tab to do nightly builds, and you are still you developers doing self-service builds, and also you are trying to store build artifacts on some web server so that test team can take that. When the intermediate step is that you have something that's built automatically on commit. So you are doing that with a Jenkins Buildbot, or maybe you have a Git post-commit hook that is doing that kind of hack. So some people have that. You may have dependency repository, so that is like the RPM system that is storing the dependencies and is able to get the dependency RPM. And you also secured your config, so your config is on control system. So the advanced, then you have triggered builds, so your developers are able to do builds on a build cluster, and the extreme is you have gated commits. So gated commits, so you cannot commit until you have passed the tests. So basically, I think that the industry norm is like this. So we have nightly builds, you have weekly builds, and the people that are using Buildbot, I think usually they are there. So maybe they are using build and commit. This is very easy to do on Buildbot. Maybe they have some triggered builds. Maybe they can propose their developers to customize the builds. So this is the first part. Now we want to automate part of the process, of the Android process. So how do you do that? So here is what is the maintainer job when you don't have Buildbot. So you get a bunch of patches from a developer, and he say, hey, this is the URL for this patch, this patch, this patch, this patch. Please integrate that and verify. And what the developer has, what the integrator, the maintainer has to do is he has to cd to the proper directory, and then he has to copy paste that URL, which is basically doing a git fetch and then a git cherry pick, and he has to do that for each and every patches he wants to work on. So this is very, very annoying for the maintainer, and it's also very error prone. So basically, what we did is we did a Chrome plugin. So really, Chrome is a very good browser for doing extension. It's you can do extension in like one afternoon. I did that in one afternoon. It's really simple. It's just a web page that you run when you click the button, and that can do some JavaScript and look inside the web page you are currently displaying. So what the Chrome plugin is doing, it's just looking at all the URL inside the Gerrit, and will send that to the next to the form inside Buildbot. So when you click on the button, you click build, and it will just send you into that web UI and pre-fill all the forms inside it. So basically, what we have done is for maintainers builds, we provide a web form to configure the build. So this is the web form, and then when you start the build, it will download the tip of the main line and then apply the given patch on top of it. So maybe the developer have not submitting the patch on top of mainline, so this is important to apply on mainline, and then it will build the different variants given the product targets. It will store the results and run the automated tests. So basically we have a bunch of automated tests that you can run, and the maintainer can choose which one he wants, and once this is done, you got a mail. So behind the scene of that, so for providing a web form, we have the Forescape that was upstream in Buildbot in October. This is the module to be able to configure the configuration form. And to download the tip of mainline and apply the patches, so we have the repo plugin that have been upstream in September to Buildbot. And also, for applying the given patches, so this is a kind of thing that is difficult because you have to get the dependencies. You have to think about, hey, this patch needs this other one patch, and how do we do that? So Gerrit has some of the information. So here you have the dependency information. You know that this patch is depending on this other patch. So, and also what we are doing is we are asking our developer to add the Bugzilla ID inside their commit comments so that we can extract the Bugzilla ID and fetch all the patches that have the same Bugzilla ID together, so that if there is dependency across products, then you can download the two patches at the same time to make sure that the dependencies are taken care of. So how does Gerrit work? So it's kind of a nice way of doing. So this is a Google framework that allows you to do everything of the UI in Java, and then some part of the Java, it will recompile it in JavaScript, and you can basically put the interface at some point, and the two parts of the web server will communicate via JSON. So here is the JSON API. You can see that if you are using the Chrome debugger, you can see actually the JSON payload. You can see here is the method change details and the parameters, the ID of the patch that we want to have the change details. And when you look at the answer from Gerrit, you have a JSON encoded response with a lot of information about your change details. So with this, you can do a lot of decision. So you have the project name you can pass to repo download. You have the dependencies you can work on. You have the subject of the message, the full message. You have the created on. You have the name of the verifier, etc., etc. So you can do a lot of things with that. So this is why I have written TX Gerrit. So this is a Python module that is able to communicate with the web UI, the JSON API of Gerrit. So it has been implemented in Twisted so that it can be integrated inside Buildbot. You can use a proxy. It has high performance. It uses PeopleLive. It can use several connections at the same time, and also it does some data caching. So it's not yet open source. We want to put that open source quite soon, but it needs to be cleaned up first and released. So the alternative of using the JSON API, it's the SSH API. I'm sure that a few of you are using it already. So you have this API Gerrit query, and you can ask for JSON, and you just submit a query as you would submit it inside the web UI. So the problem is you don't have all the information that you would have on the UI. It's kind of limited. And also this is SSH. You have to do it. It's much more slower than just a UI, which is simpler. So then part of our process is autolit. So basically, basically there is two types of automated checks. The first type is autolint. So when the developer is doing repo upload, we will download the tip of mainline and trying to apply the patch, and then we run check patch, because often the developer just forgot to run check patch, and there are some warnings, and we want to have our code fixed of all those warnings. So usually you will have like in 10 minutes after the repo upload has been done, you will have feedback, an email sent to the user, hey, you are not passing check patch, just go ahead and fix your code. So it's not part of the second check, which is auto build. because auto build is much longer. So auto build is just take the patch, apply it, and build a full image on the most important variant. So this is more like we want to support some of the variants, and maybe the developer didn't verify on all the variants, so we are doing it for him automatically, like 1 hour after submission. Then he will have a feedback on whether or not it builds. So the challenges of this is that when you have automated checks, often if you are not doing your dependency quite good, if you may have some other checks problem, then the developer will just start to ignore it. So you really have to fight against those false positives, because it doesn't make sense if the developers ignore it. Also, you have to really be careful about the message you put on Gerrit. It's just not, hey, here is the result and you have to click on this, because the developer will never click on your link. You have to extract the part of the status that is important to the developer, so that he just doesn't have to read, to click on the links. And also the very challenging stuff is the delays, because a lot of people are just like committing at the end of their day, so you have a lot of peaks of activities you need to handle into your build servers. So now we are starting to become advanced continuous integrator, because you are doing build on commit, so this is auto lint, auto build, and we are doing triggered build, which is maintainer build. But what we can do next, maybe we need to prevent people from committing bad stuff. So what we really had as an issue before is that when a developer was doing reposing, he didn't knew exactly if the mainline was in a stable stage, because maybe so before what we had is we just separated the maintenance into several components. So each maintainer was maintaining this and this component, and he was supposed to do the submission. But what if there is one guy that is in China and another guy which is in the US? Then you have this bunch of patches you want to merge, but they are dependent on each other. So the China guys, at the end of his day, will just merge his patches, but during all the day, you will have bad state of mainline, because the US guy is not woken up and didn't merge the dependency yet. So this is really an issue. So we want to have an automated process to do the merge and to verify that the mainline is stable 24 hours a day. So this is our Buildbot-centric integration process. So what my manager have done is a cactus architecture, because manager they like names. So he found a bunch of acronyms for all those. So continuous automated checks and tests. So around Buildbot, so you have the build system. You have the automated code quality checks, which is the auto lint and the auto build. All this is connected with Buildbot, with Gerrit and the Gerrit mirrors. You have a bunch of build servers, so that you can do your builds quickly. And you are having some build scripts in order to integrate all those stuff. And you have a bunch of tests that you can run whenever build is done. So here is the build sequence, so the life cycle of a patch. So basically, when the developer is sending it, we have auto build, and then the automatic code quality check. So this is done very quickly, and once the developer is happy with this code quality check, then he will send that to the maintainer, who will done a maintainer build, and then you have the pre-acceptance checks and tests, and also part of the CTS. And then once the maintainer is happy, he will promote the build for merge request, and then you have essential tests that will be running. And after that, you have the mainline, and we are doing like latest builds, weekly builds, and external release, like every other process. So the merge request, so it's basically like a maintainer build, but the maintainer builds, it's doing some more tests. It's verifying that the patch is really verified and approved. So there is a code review done. It verifies that the Bugzilla are in the correct state, and it redo the check patch to make sure that the check patch is okay. It redo a build. It tests the essential features. So basically, if the Wi-Fi is working and so on, I have another slide on that. And if everything is okay, then it controls Gerrit to automatically merge the patches inside the mainline. So now with this, we don't have maintainers anymore that are merging the patch manually. Nobody has the rights to do it except for the Buildbot user.
So why are you rebuilding again after?
So why I'm rebuilding again? So this is my next slide. Part of my next slide. So the other question is why we got often is why are you parallelizing the merge? The thing is, at one place you have the mainline. So I call it mainline is M. So after a while, you want to merge this patch at A. So you have to build N plus A. So maybe when you did your maintainer builds, you were at N minus D minus Y minus Z. I mean, it's not the same mainline. It was already built, but not on the same mainline. So you have to redo your build on the new mainline. So you rebuild on the new mainline, and you verify that it's still working on the new mainline. There is no conflict compared to what was merged just before. Okay? And if you were doing parallelized merged, you eventually have mainline is M plus A when the merge A is done, and when you merge B, you will have mainline which is M plus A plus B. But what you did actually test is M plus A and M plus B, but you never tested M plus A plus B. So that means if there is a conflict between A and B, then you are screwed up and your mainline is not stable anymore. And you may bother your developers with unstable mainline. So we really, really want to have stable mainline. That's why we take the time to redo the build, and we take the time to redo the tests. Okay. So essential tests, basically this is the test that we have to decide what we really want to do in the merge request. So as the merge requests, they are done sequentially, serially. We really have to choose what kind of really features are essential to us, and what other features can be delayed to later. And if it's broken, then it will be discovered later. So basically we have, for now, 11 tests. It takes 30 minutes to run, and we are wanting to decrease the time of those tests to be able to add more 15 tests. So usually what we have is like 15 minutes build, and then 30 minutes tests. So this is basically the time of our merge requests. Then also we have MTBF. I don't know if some people here are familiar with MTBF. So basically it's a feature asked by the operators. So operators, they want to know my user after what amount of time your phone will crash. So basically what we are doing, we are taking a lot of phones together, and we are having automated tests that basically use the UI, takes photos, look at the photos gallery, then make a phone call, then etc. etc. So there is a bunch of tests that is given by the operators, and we have that running automatically. And the thing is, if we are running 10 hours and we have 10 faults and we only have one failure, then that means we have 100 hours run with only one failure. So MTBF mean time between failure is 100 hours. So also we are running Monkey Test, which is an Android test suite that is just giving random event in the UI, just stressing it even more than MTBF, because MTBF this is a little much slower because it really waits that the UI reacts to that, because the MTBF it needs to really use the phone and make sure that the UI is answering correctly. So Pact is a new project that we are running on. It's for working with the domain teams. So usually the domain teams, they are like working a bit to have their unit tests running, and they also have some kind of pre-integration tests that are partially automated, and we really want to have cooperation between all the teams inside the company to be able to run in the same environment and to run in a clear environment our tests. So basically what we want to do is to have to share the infrastructure, to share the test machines, so that the system tests can use the same test machines, and the domain teams can also use the same machines and use the same tools to run their tests, so that we are really sure that everybody is using the same environment and not something that only works in their sites. Okay. So then we have CTS. So CTS is something that is provided by Google. So it's automated tests harness. So Google want to verify that really your device is supporting all the APIs of Android platform. So he has a lot of tests to verify that. It takes 5 hours to run on Gingerbread. So it's a bit long. And what we are trying to do is to split the test per domain, so that we can say this is the camera test, and we include that in the domain test for camera. So the next challenges. So one of the things we have is we are a multi-site company. So we have people in China, some people in Bangalore, some people in France, in Finland, in the US. And the thing is, if we are concentrating all the build slaves in Toulouse, for example, then we don't have the inter-site bandwidth is very expensive. It's not very efficient. And then you have builds that are like 200 megabytes, and each of the time you have to download 200 megabytes from one site to another. So what we do is we have several sites. On each site where there is a lot of developers and maintainers, we have some build slaves that are able to run it, and the storage server associated to the build slave. So the builds are stored near the slaves, and the maintainers can choose when you start the build in which site the maintainer build will be done, so that it can download faster when this will be done. Then also a very important challenge is the split of the tests. So basically we have the system team that is doing a bunch of tests. Usually when you are building tests, you are taking your time because you don't want your test to give false positive. So you want to sleep 1 second after having touching the UI to be sure that the UI has reacted, etc. So the tests are usually quite long, and especially when you want to do a lot of tests, it becomes even longer. So what we want to do is to just buy a lot of hardware and parallelize the tests, So we want to split the campaigns, and we want to split each test, each campaign into a bunch of tests that we can send to each slave. So basically, we split the campaign, we send to several slaves, and we have some policy based on which slaves are available and which slaves are capable of what tests. And so we want to gather the results once it's finished and present a report. So we don't want to click on each results individually. We want to have a report gathering. And Buildbot is not very adapted to that. So unfortunately, the Migo project did actually build OTS. So OTS is for Open Test Server or Suite, I don't remember. And basically it does exactly that. It split the campaigns, send to several slaves, and gather the results. So what we want to do is to use these OTS tools instead of Buildbot to manage the test build. And Buildbot will just call this OTS whenever it needs a test with some parameters. Also, the challenges of this kind of continuous integration is if a patch breaks stability. So the problem is when you have a patch that just introduces a stability issue, it means that it works one times out of 4, and it fails three-fourths of the times. So there is one chance over 4 that actually the merge request passes, and we have seen people just try again and try again the merge request until it actually passed. And actually, they were thinking that the test suite was just unstable, and this was because of the tests. So the test was bad, so just retry and retry and retry, and we eventually finished having actually the patch was unstable. And once you have this patch entering the mainline, then all your next merge requests will have the issue. So three-fourths of your merge requests will fail. So it's not very good, and we need to have support people that are always looking at the merge request. And we have made change on Buildbot to kind of send alert if there is like too many merge requests failing one after the other, then this might be because some bad patch has entered the mainline. So we have to react quickly to figure out which one we have to revert. So then another very important problem we have is first, we actually we always use Cketch for running our builds, but actually by default Cketch is 1 gigabyte cache, and it's not enough. If you are looking at your cache hit, if you have a cache size of 1 gigabyte, you have 0 hit, because the cache is always writing over and over itself. So you have to increase the Cketch max size to at least 20 gigabytes to be able to actually use Cketch. So this is a very important step that decreased our build from 45 minutes to 10 minutes per full build, per target. So then when we want to decrease this time under 10 minutes, we maybe want to do incremental builds. So incremental builds is just like in your build slave, you are always doing builds. You are always doing like mainline plus 1 or 2 patches, but overall it's kind of the same thing. So why do we want to rebuild everything at each time? Why don't we use incremental build? The problem of that is it's the make files as they are written are not so good in tracking all the dependencies. There are some basically, for example, the build.prop is not rewritten every time. So if you just modify something in the make file that change one of the build properties, then your build.prop will not be rebuilt, and you eventually have issues, and you don't know why this build.prop, this patch is not working. It's just because your build was incremental and it has to be full. So this is really an issue for us. And I don't know if you know Fabricate. So Fabricate has it starts with a great idea is to just use strace, and you do strace over your full builds. And strace you can trace open and execv. So basically what you do is you track what command you are running, and once you are in the command, you are tracking which files are open and closed, which files are written, which files are read. So the files that are written, you know if some other files are read in the same process, that should mean that the read files, they are dependency on the file that was written. So this is how we can build an effective dependency tree. And we can compare this dependency tree with the makefile generated dependency tree. You have option to makefile that where it sends you a bunch of tree thing, all the dependency for each file. So we could try to compare those dependency tree and figure out if it's the same, and if we could add some more dependencies inside our makefile to make this work better. Also, in order to accelerate the builds, maybe we can use more pre-build, but it's kind of difficult issue because the issue with pre-build is when are you rebuilding the pre-build. So it's easy for kernel, because kernel, you know, when you have a patch to kernel, then you have to rebuild your pre-build. But what if you have a pre-build that is actually depending on kernel headers? So when you have the kernel header that is changing, maybe the kernel is just changing ioctl ID, and you want the libraries that are using the ioctl IDs to be rebuilt. And how do you know that actually this library was depending on this kernel header? It's quite a difficult problem. So I don't know how to resolve this problem without having very complex dependency tree automatically done. So yeah, basically this is the end of my presentation.